Welcome to MS class. Till now we discussed about the exercise 5.1 and 5.2 Euclid's introduction to Euclid's geometry, and today we'll discuss some extra problems related to Euclid's geometry. Okay, let's see the questions. What are the questions? Question number 1: if Q and R, three points on a line, and Q is in between P and R. Q is in between P and R. Okay, then we have to prove that this one PR minus QR is equal to PQ. So this is the diagram. These 3 points P, Q, R. Q is in between P and R. What do you have to show? PR minus QR is equal to PQ. Okay. From this diagram, what we get? From the diagram, it is clear that PR is equal to what? PR is equal to PQ. PQ plus QR. We can write PR is equal to PQ plus QR. Okay. Now, if we subtract QR from both sides, subtracting QR from both sides. If we subtract QR from both sides, what will get? PR minus QR is equal to PQ plus QR minus QR. And here we are using the third axioms, Euclid's third axioms. What is the third axioms? Equals are subtracted from equals, then the remains are equals. So equals, these two equal parts are subtracted from the equals, and the remainings must be equal. So what will get? PR minus QR is equal to this QR cancel, we will get PQ. So this is the proof of the first question. Second question, what is the second question? Solve the equation x minus 5 is equal to 15. Okay, state the axiom that you have used here. First you have to solve it. That means we need to find out the value of x. So what do you have to do? We have to remove whatever the things with x that we have to remove. Here it is given x minus 5 is equal to 15. Minus 5. So if it is minus, then we have to plus. If it is plus, then minus. If it is multiply, then we have to divide. If it is divide, then we have to multiply. That process we have to apply. Okay. So x minus 5 is equal to 15. So on adding 5 to both sides, how do we get? X minus 5 plus 5 is equal to 15 plus 5. Here, how do we have to use Euclid's second axiom? What is this Euclid's second axiom? When equals are added to equals, that equals is added, 5, both the 5s are already, these two are equal, and equals are added to the equals, then the whole are equals. Whatever the result will get, they are also equal. So minus 5 plus 5 cancel. So what is the remaining in the left hand side? Only x will remain, and the right hand side what will get? 15 plus 5 is equal to 20. So what is the value of x? X is equal to 20. So in this we have to solve by Euclid's axioms. Okay. Next question, see. What is the question it is given? Question number 3. Here in the diagram given, is given. What is the diagram given? AC is equal to XD. AC is equal to XD. This AC is equal to XD. This is given. Okay. AC is equal to XD. This AC is equal to XD. It is given. AC is equal to XD given. What we need to show? AB is equal to XY. AB is equal to XY. That we need to show. So condition is given. What is the condition? C is the midpoint of AB, and D is the midpoint of XY. So solution what will write? C is the midpoint of AB. C is the midpoint of AB. It implies what? AC is equal to, that is twice AC. Twice AC is equal to AB. We can write. Again, D is the midpoint of XY. D is the midpoint of XY. So what we can write? Twice XD. twice xd is equal to xy. Okay, but it is given what? Given AC is equal to xd. We can write this one, number 2, given AC is equal to xd. Okay, one thing is that double of the same things are equal to one another. That also one example. So double of the same things are equal to one another. So what we can write? Twice AC is equal to twice xd. Here we can write double of the same things are equal. Okay, that means what? From now it is double of the same thing. So using 1 and 2, what will get? Twice AC is equal to what? AB. AB is equal to what? XY. So this is the proof of the question number 3. Okay, next see. Next, what is the question given? In this figure, angle 1 is equal to angle 3. Angle 1 is equal to angle 3. Angle 2 is equal to angle 4. Again, angle 3 is equal to angle 4. Angle 3 is equal to angle 4. This is given. We have to make the relation between 1 and 2. So given angle 1 is equal to angle 3, this is number 1. Angle 2 is equal to angle 4, this is number 2. Angle 3 is equal to angle 4, this is number 3. Okay, according to the first axiom, what is the first axiom? Things which are equal to equal things, things which are equal to equal things are equal to one another. By first axiom, using first axiom from 1 and 2, it implies, what will implies? Angle 1 is equal to angle 3. Angle 1 is equal to angle 3. Angle 2 is equal to angle 4. 1 and 3 will apply. 1 and 3. Angle 1 is equal to angle 3. Angle 3 is equal to angle 4. So what will get? From 1 and 3, angle 1 is equal to angle 4. Angle 1 is equal to angle 4. From 2 and 3, it implies, what will get? Using first axiom for all these cases, 2 and 3, what will get? Angle 2 is equal to angle 4. Angle 3 is also angle 4. So angle 2 is equal to angle 4. So angle 1 from 1 and 3, what will get? Angle 1 is equal to angle 4. Okay, this no need to write. This is number 4. Apply this one. This is number 4. Angle 1 from 1 and 3, what will get? Angle 1 is equal to angle 4. Okay. Again from these two, from 2 and 4, from 2 and 4, what we can say? Angle 1 is equal to angle 4, angle 2 is equal to angle 4. So what we can say? Angle 1 is equal to angle 2. Okay, this is the proof. See carefully, you see, from these two, number 1 and number 3, angle 1 is equal to angle 3. So angle 3 is equal to angle 4. So from here what we can say, angle 1 is equal to angle 4. So we are getting the relation. This is relation number 4. Now using this relation number 2 and number 4 with the same axiom. Axiom number 1, angle 2 is equal to angle 4 and angle 1 is equal to angle 4. So angle 4 and angle 4 are equal. So angle 2 is equal to angle 1. So we are getting angle 1 is equal to angle 2. Okay, this is the answer. Next question, see question number 5. What is the question number 5? Read the following statement carefully. A square is a polygon. A square is a polygon made up of 4 line segments, out of which the length of 3 line segments are equal to the length of 4th. Okay, length of 3 line segments are equal to 4th one, and all its angles are right angles. All its angles are right angles. This is the statement given. Be careful. Define the terms used in this definition which you feel are necessary. Are there any undefined terms in this? Can you justify that all the angles and sides of a square are equal? Can you justify that all the angles and sides of a square are equal? First, undefined terms. What are the undefined terms here used? Undefined terms we can say point and line. Here undefined terms we can use as a point and line. Okay, these two are undefined terms, point and line. Automatically it is coming. We cannot define it. And term need to be defined. What are the terms need to be defined? First one is polygon. Square is a polygon. So what is polygon? A simple closed shape made up of line segment. A simple closed shape made up of line segment, we can say line segments made of more than 3 line segments, made of more than 3 line segments. Three or more, made up of more than 2 line segments, you can say. You can start from 3, that is triangle is for 3, 4, 5. There is a triangle, the quadrilateral, pentagon, hexagon, these are polygon. Okay, so it is a simple closed curve, a simple closed shape made up of 3 or more line segments, made up of 3 or more line segments. So line segment is a part, it is a part of a line with 2 endpoints, with 2 endpoints. We can define in this way. That already you learn in class 5, 6 these things. Angle, what is the angle? A figure formed by 2, a figure, in simple way you can define it. A figure formed by 2 rays. A figure formed by 2 rays with common initial point, they have the same initial point, like this is this common point, this form an angle. Right angle, what is the right angle? Angle whose measures is 90 degree, whose measures is 90 degree, that is the right angle. Okay, now this is the first term. First things, define the terms and used in this definition which you should feel are necessary. Are there any undefined terms? Up to this must finish this answer. Okay, now next question, can you justify that all the angles are equal? First question is that all the angles are equal. All the angles are equal. Why all the angles are equal? Because all, as per the axioms, what we can say, fourth postulates, not axiom, fourth postulates, all right angles are equal to one another. All right angles are equal to one another. In squares, all are right angles, so all angles are equal. Okay, that we can write. All right angles are equal to one another, so we can write the all angles are equal. And next question is what? Are the sides of a square equal? Yes. Why? It is given that here it is given, see, a square of a polygon is made up of line segments. Out of which length of 3 line segments are equal to the length of the fourth one. So what you can say, the line segments are equal to the fourth line segments. It is given 3 line segments are equal to the fourth line segment. In a square, 4 line segments are there. So 3 are equal to the fourth one. That means what? Therefore, all the 4 sides of a square are equal by Euclid's first axiom. So what is the first axiom? Things which are equal to the same thing are equal to one another. Okay? Things which are equal to the same things are equal to one another. That we have to use. Hope all of you understand the things. If any doubt, just inbox me. I'll try to make you understand. Thank you. Have a nice day.